crucial skill that you must have is being able to identify the gradient and the y-intercept from a linear equation. The most straightforward way of doing this is when you can read it directly off an equation that's in slope-intercept form. So the equation must be in the form y equals mx plus c to read the gradient and the y-intercept off directly. So if the equation isn't already in this form, there are two things that you must make sure of. The first one is that you must make sure to make y the subject. So you must transpose it, which means you are moving it. So if you have an equation where you've got y plus 2x equals 3, you need to get rid of the 2x over to that side. The y must be on its own so that it looks something like this, with whatever your equation is over here. Secondly, it is important, very, very important, crucial in fact, that y has a coefficient of only 1. This y here has a coefficient of 1 because there's nothing written in front of it, which means automatically it means there's only one lot of y. If you have two lots of y, being 4x plus 7, you absolutely cannot plot this line at a y-intercept of 7 and use a gradient of 4, because that is not right at all. Because this 2 is multiplying the y, you need to divide by 2 to get rid of it, which means this whole equation needs to be divided by 2 before you can use it to read off your gradient and y-intercept. What I want you to do now is I want you to have a look at the following equations, and I want you to determine which of them are in this form already, y equals mx plus c. So you are looking for equations that have y as the subject and only a coefficient of 1 in front of the y. And the ones that you determine aren't in the right form, I want you to tell me why not. So have a look at these. I want you to pause the video and decide which ones are ready to go and which ones aren't. Okay, hopefully you came up with these equations being in slope-intercept form and ready to go, ready to read off gradients and y-intercepts. So obviously here we have y on the left, it's the subject, and the invisible one sitting in front of it. Same here. You might have been tricked by this one because I put y on the right hand side. Now traditionally we have it on the left hand side, but it is still by itself on one side of the equation, and it still has a coefficient of 1. Same thing here, there's no plus c because this line is going through 0, so you don't write plus 0, there's no point writing that. So if you got tricked by that one, make sure that you don't worry about there not being a constant term on the end there. This is in slope-intercept form. Same thing with this one here. We have y on its own with a coefficient of 1. It doesn't matter that there is no plus mx on this side, because here m is 0, 0 times x is 0. If we wrote plus 0 every time we had 0 on the end, we could write it on the end of every equation. We could write plus 0, plus 0, plus 0, plus 0, plus 0, but we don't. Okay, so don't worry about those ones. Now, these are the ones that you should have said are not ready to go. And your reasons should have been, there is a 2 here. It's not a 1. Here we had a 6x and it was a negative 1 as well. Here we have 7y, so we would need to divide all of this by 7 first. And here, again, not a 1, but a negative 1 is the coefficient of y. So you could easily change this into being in slope-intercept form by saying, well, if negative a number is 30, then that number must be negative 30, because a negative times a negative is a positive. Okay, you just move that negative from that side to fix this one up. Have a look at this table. I've got lots of examples for you to have a go at to see if you can pick out what the gradient is and what the y-intercept is for these lines. So I'd like you again to pause the video, quickly copy down this table and have a go at identifying the gradient and the y-intercept. Okay, so what I'd suggest that you look at first is, obviously we've just spoken about having y the subject with only a coefficient of 1, and you can see that all of these equations here satisfy that. The y is sitting on the left, they all have a coefficient of 1, so these ones are ready to be read straight off from here. Here we have some things that are a bit different. We have a 2 in front of the y, we have a 5, and here we don't have a y at all, but we'll get to that in a minute. So first of all, the gradient, which is m, so m is the coefficient of x. The coefficient of x means the number that sits before x. So here the gradient is 3. Don't ever, ever, ever write that a gradient is 3x. X is not part of the gradient. The gradient is the coefficient of x only. So, yep, we've dealt with this one. And the y-intercept, you should be looking here, but you should also be taking this into account. It's not just 4, it is negative 4. Okay, this next one here, hopefully it was straightforward that the intercept was 20. If you weren't sure about what was happening here, the gradient is just 1 over 7. Because remember, 1 over 7 times x can be written as x over 7. Okay, so the coefficient, the part that is sitting out the front of the x, is 1 over 7. And that just means that this graph will rise 1 each time it runs. 1, 2, 3, 4, 5, 6, 7. So it's not going to be a very steep graph. Here you should have been very, very careful because the coefficient of x, it's not sitting up the front here like it is in these first two. It's sitting over here, and that negative is associated with that number. So the gradient here is negative 5. The line is going down. And the y-intercept is 3. Here we have an invisible 1 sitting in front of the x. If you said 0, you were wrong. If there was a 0 sitting in front of the x, 0 times x is 0x, which is 0. So only when you don't see an x at all is the gradient 0. So here it's 1. And y-intercept is 12, positive 12. And it's probably a good idea to put your positives on here just so that you know for sure when you go to graph them that it is a positive and you don't have to go back and double check, is there a negative here. Okay, for this one here, we've got our plus c, so our constant term 16, that is where this line is going through the y-intercept. Now, what's the coefficient of x? Because the x is not written there, the coefficient must be 0. 0 times x is 0, just as I was explaining here. So for this line, the gradient is 0, which means no rises for any number of runs. It's actually a horizontal line. I've got a video covering 0 gradients and undefined gradients that you should also check out. Okay, this one here, to be able to use this one, you would need to divide the whole thing by 2. So 2y divided by 2 means you just cross out the 2. That's the whole point of dividing it by 2. Equals 9 divided by 2 minus 3 divided by 2, x. And you could put the x sitting on top of the fraction bar or just out next to it. Either way is fine. So this one here is the constant term. It's a number only, no pronumeral. That is the y-intercept. So 9 divided by 2. You can think about this as how many 2's are there in 9? There are 4 and 1 left over. 1 over 2 is 5, so it's 4.5. Now looking at our gradient, first of all it's a negative, so don't forget to straight away put that negative in, which means this line is going down. So from left to right it is going down. And 3 divided by 2 is 1.5. So this line crosses the y-axis at 4.5, positive 4.5, and then it goes down 1.5. And it's probably actually, you could even leave it in this form here, negative 3 on 2, because for gradient that's easier because that's telling you it's falling 3 for every time it runs 2. So you can have a particular point that you're starting from, might be the y-intercept, and you can go down, 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 so a fall of 3 and a run of 2 across, across. Plot your next point, use a ruler to draw a beautiful straight line. Okay, this one here, the whole thing needs to be divided by 5, so we go 5y divided by 5, gets rid of the 5, which is why we're doing it. 2x on 3, first I'm just going to write this out. Now this will be easy here to divide by 5. This one here we're dividing by 5, which really means you can also think of this as timesing by the inverse, timesing by 1/5. So 2 on 3, 2x on 3 times by 1 on 5 is 2x times 1 and 3 times 5. So hopefully you can see that we leave this alone. When we're dividing by 5, we leave this alone and we're really just multiplying the bottom, the denominator, by the 5. So that becomes 2x on 15 minus 25 divided by 5 is 5. So our y-intercept, negative 5, and our gradient is positive 2 on 15, which means we rise twice and we run 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is an even less steep line than the one that we had up here, which was 1/7. Actually, it's only slightly less, because technically if we simplified 2 on 15 to get a 1 on the top, so 2 divided by 2 to get 1, 15 divided by 2 will actually give us 7.5. So it's only slightly less steep than the line from before. Now this one here might concern you because we don't have a y, so how could we possibly transpose it to make y the subject? I mean, technically we have plus 0y. You could write that on either side, but this is not going to work, because if we want to make this, if we want to make y the subject here, and let's just write it over here again, x equals 2 plus 0y, I could say 0y equals x minus 2, so I've minus 2 from here, minus 2 from here. But to get a coefficient of 1, you know, divide by 0, that is an absolute no-no in maths. You cannot divide any number by 0, and if you do, I mean, try it on your calculator now. If you do, it's what we call undefined, because it's not possible. This x equals 2 means that for your Cartesian plane, the only values where this line is are ones where x is 2. So that's x is 1, x is 2. X is 2 here, x is 2 here, x is 2 here, x is 2 here, 2 here, 2 here, all the way up and down. So really this line, if I drew it straight, is going along at x equals 2. So y-intercept, well, is it going through the y-intercept? No, so not applicable. Or like, don't ever write 0 because it's not going through 0. Just write not applicable or not relevant, or I guess just a dash would be fine too. So hopefully this video has clarified for you how to determine the gradient and the y-intercept from a linear equation. You should now know that the easiest way to do that is to transpose your equation into slope-intercept form, which means making y the subject and making sure the coefficient of y is 1. Now it's time for you to have a practice. Thanks for watching.